Okay, so it's Jamie Smith here. I'm doing the second problem on the 2004 free response. It's a pretty easy problem. So if you're looking at this and you consider yourself pretty good at mathematics, you can just skip over this one because Mr. Shan told me it was an easy one. That's probably why I'm doing it in the first place. Okay, so you've got your two equations. You've got f of x and g of x. So the first question asks you to find the area of the shaded region enclosed by the graphs f and g. So you've got f right there, you've got g right there. And so you know that since this is a calculator problem, you can plug in f of x into y1 and plug in g of x into y2. And then this is your integral right here. That's how you'd set it up. And then when you plug it in, do f and int y1 minus y2, because as you can tell, f of x is above g of x, and f of x is y1. So y1 minus y2, comma x, comma from 0 to 1, because 0 and 1 are your points. Strav, how's it going? It's making my math video. And so, you plug that in, and you get 1.133. Remember, 3 decimal places, so make sure to do that. All right, and then B is asking, find the volume of the solid generated when the shaded region enclosed by the graphs of f and g is revolved around about the horizontal line y equals 2. So I drew my graph right here with the horizontal line at 2, and so then since you want to find your outer and your inner, you draw your section, you draw your lines. So then you know instead of it being f of x minus g of x, it's g of x minus f of x. But since you're revolving it, you need pi, you have it squared, and also since it's about the horizontal line 2, you're going to have 2 minus, so this is what your entire integral is going to look like. It's going to be 2 minus g of x squared minus 2 minus f of x squared, from 0 to 1, and then after that you're going to multiply by pi, and your final answer comes out to 5.150 pi. You can just leave it in terms of pi. That's an acceptable answer. Okay, and then C is saying let h be the function given by h of x equals k times x, 1 minus x for 0 to x, 1. Hi, Adrian. I'm doing my math video. Show some respect. For each k is greater than 0, the region not shown enclosed by the graphs of h and k is the base of a solid with a square cross-section perpendicular to the x-axis. So you just note that square cross-section. That's very important. There's a value of k for which the volume of this solid is equal to 15. Write but do not solve an equation involving an integral expression that can be used to find the value of k. So right now you know that you don't need to solve it, you just need to set up your integral. So we're going to go down to C. So we know h of x equals kx times 1 minus x. So we know that it's going to be the integral from 0 to 1, h of x minus g of x squared, dx equals 15, and it's squared because it's a square cross-section. As you can tell, h minus g of x, or h of x minus g of x times h of x minus g of x equals is the area of the square, so that's why it's squared. And so then you can just plug in what h of x equals down here. So it's integral from 0 to 1 k of x times 1 minus x, and parentheses minus 3 times x minus 1 square root, and square all of that. Dx equals 15, and that's going to be your answer. And that's how you do these problems. Generally speaking, there's some sort of problem on the AP where you have to find the area of the graph and then revolve it, so it's good to know this stuff and make sure you know it. It's very important. And so that's the video. And I think this really covers everything. It's very important to know that. And if you have any questions about this math video, I recommend you call the number, or it's a math helpline. Call the number 301-802-0575. This guy will really help you out. He's a good math expert. And hope you enjoyed the video.